So now we're going to move on to our third topic, which was indexed collections of sets. And again, I'm going to remind you of some notation. I'm not going to recall everything from this section, so you might want to go back and relook at your notes or those videos. So remember that in the videos, we defined AI to be the collection of elements X, where X is in AI for some I, where I is between 1 and n. And then the intersection means that it had to be in every set. AI for all, or for every, say for every I, where I is between 1 and n. So something you might want to note here is these correspond to our quantifiers. The union corresponds to our existential quantifier, and our intersection corresponds to our universal quantifier. And so from this, we can now define an infinite collection of sets. So, for example, if I take the union from I equals 1 to infinity of AI, this would be all the elements X, where X is in AI for some I in the natural numbers. And then the intersection would be the collection of elements that are in every AI for every I in the natural numbers. So what I want us to do is revisit an example we looked back when we were first discussing this material. And so let's say I define for each n in the natural numbers, I'm going to define an to be the interval -1 over n to 1 over n. And I want us to find the union of AI and the intersection of AI. So it might help if we write out what some of these intervals correspond to. A1 would be the interval -1 to 1. A2 would be the interval -1/2 to 1/2. And A3 would correspond to -1/3 to 1/3. So let's draw these intervals visually on a number line. Here's 0, and I'm going to try and line them all up so that they're in line with each other here. Okay, so the first one goes from -1 to 1. So including -1, including 1. So then the next one will be -1/2 to 1/2. And then -1/3 to 1/3. So if you'll notice, the interval is always centered around 0, and all that's happening is the interval is getting smushed on both ends closer to 0. And so now if I look at these sets, right, what happens is A2 is a subset of A1, right? And then furthermore, A3, it's a subset of A1 as well. And so what's happening is these intervals are shrinking down, but every successive interval is a subset of the first interval. So if I'm looking for the union, it'll be the first interval, -1 to 1. Now, the intersection, what's happening is, kind of think about the two endpoints of your interval. They're being shoved in towards 0. Successively, they're just being shoved more and more in, so they're getting closer and closer to 0, which means that the only thing these sets are going to have in common is just the number 0, and that's it. So we looked at this example last time, but what I want us to do is, we didn't prove either one of these before, so in our next video we're going to prove this union one.